my video here, and I'd like you to start up your AnyLogics. Okay? So if you have a model open in AnyLogic and you want to close it, you can do so by clicking on the model, right-clicking on the model and doing close. That right-click action on a Mac, I think it's, Dylan, is it option click on a Mac? Or two-finger click. Okay. Okay, two-finger click on a Mac. Thank you. Okay, so having closed that, ladies and gentlemen, I would like you to now start our first model. Are we ready for this? Okay. So I'd like you to start a model that's going to be called, well, I should also have my...
You can see while you're putting that, if I can get this to be any bigger than it is.
Oh, good. Oh, I see. Okay, thank you, Dylan. Okay, I'm going to be turning on this mic as well, which will help with some of the decrease the chance I'll burn out my throat each day. Okay. So a couple things here. First thing is, having done this, we're going to be situated in this interface, and right now it's not showing any model. We're going to add a new model for it to show. So if you could go to File, New, and this model is going to accompany us for the afternoon. So we're going to use it for the starting example, and we're going to use it on an ongoing basis for the next example as well. So I'd like you to call this here interacting. So interacting diabetes and weight. Okay. So that would be the model name. Now, you can name your model as you see fit. If you prefer, this is written in a style known as camel case, because it kind of goes up and down like the mound on a camel's back. And if you prefer, and you'll notice that words are separated using capitals. If you don't like that, you can put an underbar instead, okay? One of these underbars, if you find that more natural. But it's a very common style. So interacting diabetes and weight. Now, for the model time units, which is important, I'd like you to select years, okay? It's actually going to be a little bit of time before we come to the diabetes and weight component of it. That's going to rest in the second component, but we're going to put in some risk factors up front, okay? Are we ready for this? Okay, so ladies and gentlemen, model time unit is in years. Having done that, I'm gonna say finish. Now I'm gonna actually put this in a certain place that will be recommended for my particular document. So you don't have to pay attention. You folks can say finish. I'm just gonna put it in a appropriate location for me. Okay, that will help me make sure it can get quickly uploaded. Okay, so this will be this is boot camps. And boom. Okay, and Melbourne, yeah, and then come on. Okay, tutorials, Melbourne, and then we need to put it in models built in class. There we go. Okay, great. Okay, and we're going to say finish. Now, when AnyLogic creates this model, you'll notice that you won't notice because the palette is covering it. We'll want to go over here. After it creates this, it'll put some things here, including this thing called main. Go over to the projects area and click on this. When AnyLogic creates a project, it'll create two components automatically. One is this component called main, which will kind of represent the global environment, the general environment in which our potentially multiple populations will sit. Environment for describing sort of the world, as it were, to the model. In some models, including in just a moment, we're going to have additional structure, but main represents sort of the more global environment. And then there's this thing with an X. And that X, we've seen it before, and it represents an experiment, okay, a scenario, particular what if, as it were, running the model with certain assumptions, okay? You'll notice that over here on the left-hand side that you can actually click here and expand things to find out more details about the model. For now, we won't really take advantage, but soon enough you'll be exploring it here. You could alternatively explore many things over in this window, the so-called canvas window, which you can generate by double-clicking on main. Okay? Ladies and gentlemen? So what I'd like to do now is to go and add an additional piece of structure. We're going to add an element that will be an increasingly articulated theory of personhood, what it means to be a person for this model. So to do this, as in any logic, there's several ways to accomplish it. One, ladies and gentlemen, would it be to do File, New, Agent Type, okay? File, New, Agent Type, okay? I'll show you a second way, which I actually prefer, which is if you right-click on the project, you can do New Agent Type, okay? And that's pretty handy if you have multiple projects open. You can put it in the appropriate project, okay? New Agent Type. Okay, that's great. Okay. So we'll do agent type, and the name for this new agent type will be person with a capital P. Okay. Okay, so what we're just depicting is, in this model, there'll be this construct called person with a capital P. And that's called, ladies and gentlemen, it goes by the name of class. It's kind of a type of thing, a kind, a sort of thing. And it's going to depict the theory of personhood. And at any one time when running the model, there may be many particular people, but each of them is sort of, has its general characteristics of their personhood described by person with a capital P. Okay? So, as we say, there'll be many instances of person, many particular people, but their general characteristics will be specified by person. The fact that they have some diabetes status and some weight status, the fact that they have an income and they have a sex associated with them. These things will be specified by person with a capital P. Okay? So, ladies and gentlemen, I would like you to now go and within the context of this model, I'd like you to go and place something in person. To wit, I'd like you to go give person a representation visually, just so we can see where people are located. And we're going to use this to good effect to give insights about the model. Those little depictions we saw this morning, people running around, and little icons, turns out that although those seem pretty and kind of fun, they actually serve a serious purpose. They can actually highlight for you patterns that are going on in the model you might otherwise not have noticed. If you just depended on outputs of data, tables being output by the model, you might miss some very salient features. And one thing that people are very good at is we have a very evolved visual system. So when there's a pattern visually in what's going on, we can often notice it quite quickly. And so by having the model put out a visual representation, it's more than eye candy. It helps give some understanding of what's going on in the model at a given time. Okay? So I'd like to, with a nod to that, I'd like to give a person a representation here. Okay? So if we could double click on person And now I'd like to go to the palette. So we have person appearing here. Now it's very important, and I'll emphasize this again, it's very important when we're going to add something to the model, we be very clear about what's open here in this canvas. This area is called the canvas, and you'll notice there's two things here. One is main, one is person. When we add things, you'll want to consciously check, if at all possible, to which of these you're adding it, and be very clear about to what you're adding it. Because if you add it to the wrong one, you're going to get effects that are very different from what you hope for. Okay? So notice I double-click on person to get person up here, because I'm going to add something to it. I'm going to give it a representation. If we added that instead to main, we'd see something quite different. We'd be telling it to do something quite different. So I'm putting it to person. I went down here in the palette and I clicked on this presentation here, and I'm going to drag the oval over here. Okay? I'm going to drag an oval. Now, I can visually adjust this oval, or I can adjust it manually. In this case, ladies and gentlemen, what I'm going to do is I'm going to go, having selected it, its properties are shown in this properties tab. That's showing me the properties of whatever is selected, either in the projects area or in this. And I'm going to set its radius, ladies and gentlemen, to be right now be 10. Boom. Just like that. 10. Radius 10. Now I could have dragged it and done it, but I just thought it would be easy to get everyone on the same page by doing 10. And now what I'm going to do is I'm going to go drag it over this place here. Why is that significant that I'm dragging over those crosshairs? Because those crosshairs indicate the logical reference point visually for this thing relative to the logical location of the person. If this thing is located right over that crosshair, it means they will be located visually at the same place they're logically situated, which will be convenient for some reasons. We'll be able to kind of see them lined up from their position. We'll know immediately about their logical position in cases where we might be interested in it. So I just dragged it over there. If they're offset from it, they will appear offset, which will be strange, like in GIS. Their real location is on the street and they appear in the middle of a lake or something like that. That would be adverse, right? Okay. Okay, so ladies and gentlemen, we've given this person an appearance. The next thing we have to do, we've defined here a particularly simple, some people might argue impoverished theory of personhood. A person is represented as a circle, okay? Our next step, however, right now though, if we go back and we look at main, our model has no, okay, that's a theory of personhood, but there's no particular people in it. There's no people in the model. We have to add what's called a population, okay? This will be a population of people. In our model, we might have many populations. We might have a population that represents Melbourne, another Sydney, another Adelaide, another Perth. And each of them might be a population. Or we might have a population of deer and population of people. I guess you wouldn't have deer here, but you'd have roos. A roo population and person population. And they might interact in certain ways. Okay, so ladies and gentlemen, I would like you to now work with me to add a population. So I'd ask you to follow my steps. First of all, open main up. You can do so by clicking here, or you can go back to projects and double click on main. Next, once main is open, and you verify you're going to be dragging into main, this is in the foreground, you click on person and you drag over onto main. It doesn't matter exactly where you drag, although it's kind of nice if it's not right here, because this is where the that representation will appear. Now, when you do that, it will ask you for a name, and you could either fill it in here, or if you had not typed that, you could have gone over in properties and filled it in there. Like if you forgot to type it in time, as long as this is selected, you can fill it in properties. Are you okay with that? Okay. Now, there's a key additional step I'm going to ask you to undertake. Okay? Are we ready? Okay, I would like you to change this. This is a thing that you almost always do. Almost is an operative term. Almost always do. You drag this in, and if you want it to be a population, you need to do one more thing. Namely, you need to click population of agents. Okay? So it was single agent. You actually need to click population of agents. Are we okay with that? We okay? Okay. Great. Okay. So it says 100 agents. Okay, ladies and gentlemen, I'd like you to undertake another action you'll frequently perform. Saving the model. You can do so with Control S. I don't know if it's Control S or Command S or Option S on a Mac, but you could probably tell me, those with Macs. But it's also the save model, and it will tell you what it is on a Mac if you sort of highlight it. Okay. Next, I would like you to run the model. Remember how to do that? How do we do that? Anyone remember? How do we run it? Yeah, you can right-click on simulation and click run. There's actually many ways to run it. We could do so with this green button as well, or we could do so with a menu. But unless it comes up and we'll say run. Now, this model may seem inconspicuous. It may seem uninteresting, but you've created your first running model. You'll notice that there's actually a population of 100 people here. That's shown in that Da Vincian emblem. Okay? This emblem here. You'll also notice if you drag down that little menu there, that so-called navigation menu, you'll see there's a population 0.99. There's a person 0, 1, 2, 3, 4, all the way up to 99. If you pull that down, you'll see here's person 1, here's person 2, here's person 3, etc. But where are those people? Wheretofore art thou? They're up here in the upper left corner. They're all on top of each other. I want to lay them out so that they're at different locations. And by so doing, we'll both make it clear how big the population is visually, but more to the point, we'll be laying the groundwork for our next few steps, for steps, and in fact, some steps later in this course. So, ladies and gentlemen, I would like you to stop the model. You can stop it in two different ways, well, several different ways. 3 different ways I'll list. One is you could click here, or you could click here, terminate execution. It will actually go back to this. Alternatively, there's a button here, this red button back in the interface that you can also terminate it. Okay? There'll be 2 windows, one running the model and this, and you could press this button. Okay, stop model. Okay, so ladies and gentlemen, I would like to lay these people out visually, and then we're going to start using that visual layout for other reasons. Are we ready? Okay, ladies and gentlemen, I would like you to go back to main and click here on the population. Are we okay with that? Okay. Now, there's this area called initial location. Perhaps it's collapsed for you like this. If so, you want to open it. Okay? Okay? And you'll notice that within it, there's this choice, place agent, and there's a choice here at the agent animation location in the specified pointer in the node. Okay? If you could select in the specified point, it will give us a choice as to where to place them visually, and actually more than visually, logically, and the visual depiction will reflect that. So we could specify their X, Y, and Z location. Okay? Do you see that? Okay. Dylan stands ready. And he sits ready. Okay? Are we ready? Okay. So I am going to put in some formula that will tell for each person how am I going to assign them an X value? How am I going to assign them a Y value? Okay? Right now it says assign them all 0. And you could play around with that. You could all assign them 250x, and you'll see them all located at x 250 0 y 250. I'm sorry, 0 y 0. So I'm going to put in a formula that will say basically for a given person, draw that person's value for x from a distribution. Are we okay with that? And the distribution is going to reflect the width of the space. Okay? We ready? Okay, I'm going to say uniform between 0 and 500. Okay? It's going to be drawn from a continuous uniform distribution with limit 0 and 500. Are we okay with that? And let's do the same for y. You can just copy that for y. Are we okay? Okay. Okay. So, ladies and gentlemen, I'd like to run the model. But before that, I'm going to teach you something else that I'd like you to do on an ongoing basis. I'd like you to go up here. There's a thing called Build Model. Next to this green button, you see it says Build Model. I'd like you to click it. And that will basically lead to any logic telling you back, does it understand your model or not? Does it understand the phrasing of your model? If it's confused, it will tell you. It'll say there's a problem. It'll say there's an error. But if it completed successfully, you'll say down here in the lower left, build completed successfully. Do you see that? Okay. Okay, who needs Nolian help? Okay? Okay. Ladies and gentlemen, I'd like you to run the model. What should we see now, do you think? What would you posit that we'll see? Anyone? We'll see something like that. Yeah. You see that? You see that? Okay. Okay, so there's our distribution. And what does each of these circles represent? It's a particular person. Each particular person is still represented by a circle, and each of these represents a person. Okay? Okay. Now, we're going to take this a little bit further. And first of all, I want to generalize what we did slightly. Okay? So for the x and y locations here, instead of saying 500, I would like to this 500, where did that come from? Where did that originate? I pulled that out of the hat, you may think. Well, actually it reflected the width of the space and the height of the space, but I happen to know it. And you might not know it. You might forget, you might not know what the width is. So I'd like to replace this with something more general. After all, for different models, we might have different size spaces. You don't want to always just hard code it 0 to 500. So I'd like to put in another value here. You'll notice that what we're doing here is we're calling a function. Do you remember in high school you used to write like sine of 30 degrees? Do you remember that? And you put when you wrote that, if your high school was anything like mine, you would have written something along these lines. Or often you would write 30 sine of 30 degrees, something like that. And that's what this is. The thing inside the 30 degrees provides the value that sine needs to do its job. Sine needs some information. You say, tell me the sine. It will say, well, you have to tell me what angle before I can do its job, right? So these are called the arguments inside there. And in general, there can be more than one of them. Sine happens to take one, but there are certain types of functions that will take several arguments. And uniform is one of them. It takes 2 arguments. The first is 0, second is 500. It needs it to do its job. Okay? Okay, now, ladies and gentlemen, if we want it to be general, we would do something like this. Instead of giving it 500, we would ask it, let's do it between 0 and this dot space. Now I'm going to teach you a key skill for any logic. I'm starting to type space, SP, And ladies and gentlemen, I would like you to stop after the SP. It'll be space width we'll be typing, but I don't want you to type this. And it is exceptionally important that you not type what I'm going to tell you to type. Well, what I'm going to show you, okay? That sounds bizarre. I don't want you to type it. I want you to get it to complete it for you so that you don't have to type it, okay? It will actually write things for you if you know and you're consciously requesting that. If you know how to request it and you're consciously doing so. So I'd like you to type SP, and now this skill is key. So I'd ask Annie and Dylan to come help make sure everyone can do this. SP and control space. Now, some of you may be using a multilingual keyboard, and you don't want to use control space. You want to use something else. They will work to set yours up so that you can do it. If control space switches you into Dongwon or switches you into Padmani or some other language, you can work with them, and they will set any logic up so that it will not switch languages. But it is extraordinarily important for the examples of this week that you know how to use this and that you use it as a routine matter rather than typing. The number one problem people have in this course is that they try to type everything out longhand and they make spelling mistakes. They forget to capitalize something, or they do capitalize it shouldn't be capitalized, or they leave out a letter, or they type S instead of A. We want to avoid that, and it will help the TA time go for really important things. So, ladies and gentlemen, press Control Space to call up that menu. It will actually...
And for Macs, that's Option Space?
Thank you. For Macs, it's Option. So, you'll notice I did Control Space, and it will fill out all possible choices that begin with that. I'm going to go down and pick the one called space width. Notice how I'm doing this. I'm using the arrow keys. And each one I'm doing, it's actually giving me information on that. Do you see over there on the left-hand side? It's saying like space cell height returns the height of the cell in discrete space. I want to go down to space width. Do you see that? And it will say returns the width of the environment, continuous or discrete space. Are you okay with that? Control space. Okay. And then I'd like you to press enter here. Ready? Get set. Go. There we go. Okay? Okay.
As somebody who's, well, obviously I haven't spent as much time programming in life as maybe Jeff have, but as somebody who has a lot of programming in his time, using this is going to save you an enormous amount of time. Like, you just get so used to doing it rather than typing everything yourself that it actually feels really weird when autocomplete is not in a program. Like, I'll be using Microsoft Word or Facebook and I want to finish a sentence and I can't do it, so I'll just fumble around with control space. Anyway, get used to it. It will save you a lot of time. It'll save you a lot of grief, and it'll show you everything you can do in a particular context.
And it will help the TA's time go much further. For things that are really tricky rather than silly little misspellings. If autocomplete is not working, call the TA. They can help you figure out why, because it should be working. Maybe because you've copied it to main instead of person or something like that. Okay. Okay. Now for Y, I'd like to do the same thing. .sp. You could type as many characters you want. The more you type, the smaller the list will be. And here I'll do space space height. Okay. Now what's going on here? What is this? What does this mean? Well, what it means is it's first going to be figuring out the space height, and you'll notice it has a begin paren, end paren. We're going to see that a lot. That just means it's like it doesn't need any information to do its job. You don't need to give space height any information. It will just give you back, oh, the height of the space is 500. And in fact, that is the value it's going to give back in this case. And then that 500 is going to be used as a argument to as the information uniform needs to do its job between 0 and 500. So first it's going to do this, and then it's going to call uniform on that. This just means asking myself, hey, get my own space width, because I'm in Maine. And we're going to come back to that at other occasions. So I'm asking, hey, what's my space width, or what's my space height? I'm using that, turns into, say, 500, and then I ask, draw me a value from a uniform distribution between 0 and 500. Okay? So I'd like you to, I'd like to see if you could try that. Are people trying that right now? Who would like a little bit more time for that? Okay? So if we run this now, first of all, before running it, build early, build often. Use this button up here. Make sure it's a happy camper, okay? It's happy here. Mine is happy. Is yours happy? Okay. And now you can run it, and you won't see any difference. But the model's more robust now. I've taught you a life skill that you're going to be applying many times. And it's extraordinarily important. It has gravity because it'll make a night and day difference in terms of how long it takes a TI to come for you if we're all using that functionality. Okay? Okay, so there we are. We're in great shape. Okay, now I'm going to teach you another lesson here. So we've just learned something about how it does things. And we could use, instead of a normal distribution uniform, we could use normal or log normal or beta or any number of different distributions. And there's a wide variety of them. In fact, if you were to click here, there's even a probability distribution chooser up here that you could use. You see this little thing here that will help you select if you wanted a particular distribution that you could use. Right now we have a uniform, but you can see AnyLogic supports a wide variety of others. I'm going to do cancel out of this, but suffice it to say, if you want help with probability distributions, there's plenty of them. Okay, so ladies and gentlemen, I would like to take the next step, which is also of significance, but it's going to teach a very important component now. So over here in the, I'd like to go to the palette, and I'd like to go down to this area of the palette, to the agent area, okay? And in the agent area of the palette, there is a place for something called a parameter. Now, the parameter is going to be one of your biggest friends this week, okay? It's going to be a friend to which you come back again and time again. And I would like you, ladies and gentlemen, to drag this parameter over into main, okay? And the parameter will be called population size. Now notice how I'm doing this. I dragged it into main. These things, I drag it to main, they become part of main. That's the building blocks out of which I'm going to construct this model. And I'm going to have a population, a parameter called population size. And this parameter is going to encode an assumption for this model about the population size. Okay? It's going to code information about the population size we're going to use for this model. And by virtue of encoding this in main, we're going to be able to run this model with different assumptions about population size. And we could use parameters for other things to make different assumptions about those. So I just dragged in parameter size into main. Notice I dragged it into main. And there's only one more thing I need to change here. Over here in the type, if you look at the properties, this is going to be not a double precision value. It's not going to be 32.39. It's not going to be a Boolean, true or false. It's going to be an integer, 0, 1, 2, 3. Okay? 0, 1, 2, 3. So we need to label this as an integer. Okay? Okay. And having done that, I'd like to set a default value for it, which will be 100. Okay? Once again, we've made a change which will not yet directly impact what we see, but it will provide for a lot more flexibility, just like that original change. So it's going to be 100. Okay? 100. Now, there's one more thing I need to do to make this actionable, to make it operational, to actually make it be the population size. Particularly, I need to click on population, and for initial number of agents, instead of saying 100, what do you think I'll say instead? Population size. That's right. Population size. Now, if I want, I can be explicit about it, saying this dot population size. Whose population size? Mine. And I'm going to actually type that. Some of you may prefer to just say population size, where this is implicit. But I'm going to say this dot population size. My population size. My population size. Okay.
So everyone try to type this dot P.
Good. Excellent, Annie. I'm grateful for your this dot and then control space, and it will pick population size.
So we do it automatically. But
Yeah.
people might
Yeah.
every time do
Yeah.
control space.
Yeah.
And sometimes in the future you'll find that you'll discover things like doing control space. Like you'll want the function, so you can maybe call this and doing control space will give you a list of possible things that you can use.
Right. Okay. So, ladies and gentlemen, what I'd like you to do is to do this build button here. Okay. Make sure it's happy. And now I'd like you to run the model again. And you should see, should what we see be any different? No, it's because the population size by default is 100. It's still 100. But now, ladies and gentlemen, I would like you to do something different. I'd like you to close this, and I'd like you to add a new experiment. And this one will be called, big population. So how do I add an experiment? I right click here on the model. I say new experiment, and I'm going to say big population. Okay, big population. Okay, and for the big population, I would like to make it a population size of 1,000. Okay, great. And now I'd like you to run the big population. So in other words, this is a very important conceptual point. We just added a parameter. The parameter encodes an assumption, and it communicates that assumption from the point of creation to where it needs to go to. In this case, the experiment is creating main. It's bringing main into existence. And so it's the experiment that tells main what to assume for its population size. Because we put that parameter in main, for different experiments, we have the luxury of telling it what to assume for the population size. This may seem a minor matter for this, after all, population size, but this is what allows us mechanically to ask what-if questions. We'll have different experiments, and they will make different assumptions about the parameters in main. That's how we're going to go about representing experiments in this model. Parameters, okay? We're going to be asking different what-if questions by creating experiments that specify different values of the parameter for main. Okay? So it's a very important point to one of the key goals of modeling, asking what-if questions. They will be mediated by, made possible by, realized by parameters. Are we okay with that? So, could you run it? What do you think we'll see? What will we see now? We'll see more people indeed. And they will be distributed over that same space, but they will be more highly clustered, right? Okay. So that's great. Okay. I'd like to now request that you close this window, and we're going to take the learning here one step further, okay? Okay, so specifically, I would like to go now apply the same basic mechanism, adding this parameter. I'd like to apply that to a different construct, namely to person, okay? We're going to add a parameter to person. Is this okay? This parameter, ladies and gentlemen, will be a parameter which allows us to have some heterogeneity in the population characteristics, okay? So, ladies and gentlemen, I would like you to double-click on person, and I would like to go add a parameter to person to represent their age. I'd like you to tell me, where would I go in the palette to add a parameter to person? Anyone? I go to agent palette. Excellent. And what do you think I add? Okay, now when I add the parameter, make sure person is showing. You don't want it to be dragged into main. You don't want to give each main, you give main an age. You want to give a person an age. So you need to make sure person is up there. If person isn't in the foreground, make sure it is. Dylan, I was hoping you could help me with something. Thanks. So I'd like you to now go drag parameter into person. Can you give that to Jeff?
To who?
Jeff.
Okay.
Thanks. Thanks very much. So I'd like to drag the parameter into person, and I'd like to name it age here. Okay. Okay. So we've just given each person an age. And this age will be a double precision value. In other words, it would be 32.2 or 15.7 or 23.5. Okay? Okay. So we've just given each person an age. This is how we add heterogeneity to people. So when we talk about agent-based modeling, one of the foremost advantages of agent-based modeling is it allows you to capture heterogeneity in a population. Heterogeneity not only in terms of discrete attributes, we'll have males and females, and we'll be doing that in a moment, but also with respect to continuous quantities, things like birth weight, things like someone's age, things like aspects of their income. These are continuous quantities. And rather than stratifying the population into age categories or into income deciles or what have you, instead what we can do is simply add a parameter for each person. Each person knows their exact age as a double precision value. So we're going to have age here. Are we okay with that? Okay, let's go. Having done this, say the theory of personhood includes age, I would like to go and give our population characteristics for its age, okay? So the population should have some age distribution associated with it. Where do you think I would specify that for the population? Where would I go to find the characteristics of the population? Anyone? It's in main. Yeah, we go to main. So we go to projects here. Okay. Yes. Absolutely. If you wanted to do so, it's just what I'm trying to say is the lens of agent-based modeling is such that it can support continuous attributes. If you prefer to stratify it by 5-year age categories or whatever, no problem. Yeah. Oh yeah, you could certainly have that. So we could add a Melbourne population, a Sydney population. They would have somewhat different age distributions associated with each. And you'll get a flavor, I think, of how that's done in just a minute. Okay? Okay, great question. Any other questions about this right now? Or are we okay to impose an age distribution? So in order to impose an age distribution on our population, we go to main and find the population. Now, you may be wondering, well, wait a minute, why don't I specify the age distribution for the in person? Remember, person defines a theory of personhood. And then there'll be particular populations which have specific people in them that will have age distributions associated with them. A theory of personhood doesn't involve an exact specification of this person's age is such and such, that person's age is such and such. The theory of personhood involves saying people have an age. And then for a particular population, you say the age distribution is X, this such and such, from this distribution or that distribution. So let's go to the population here, and let's give it an age distribution, okay? And, we could make different assumptions about the age distribution. Does anyone feel very strongly about what age distribution to use? If you want to use a Weibull, or you want to use a Gumbel, or you want to use a beta distribution, we could do that. Otherwise, I could put in a uniform between 0 and 80 and just say, well, good enough for this little example. Anyone feel strongly? Okay, so if not, we'll use another distribution in just a moment. We'll say uniform between 0 and 80 age. Okay, great. Yes?
A question made about what you just did there is that it reminds me of sort of Bayesian approach, where you're sort of getting expert opinion on what an appropriate distribution might be in some cases. Do you apply that into the modeling process? So collective opinion about, yeah, we agree that this is an age.
Yeah, we will do that. It's a great question. And again, the name is? Colin. Yes, so great question, Colin. So there are times where we'll engage in a group model building or group discussions about a model, and we might try to solicit from a group of clinicians some understanding of how this might vary. This particular process, the time that it takes to diagnose this sort of condition, we might elicit from them some distribution. Now, often we'll have in mind a certain distributional form because they won't expect them to come up with, their knowledge of distributions might not be very strong, but we might think, well, okay, maybe triangular distribution with an upper range and a lower range and a middle or a beta distribution or what have you. But yes, eliciting that information might be useful. Partly the reason I did that was didactically. I didn't want people to think that uniform is the only distribution. I mean, we have access to all these different distributions here, and if we want to have a Weibull, we could. But I just thought I'd check if people had a strong opinion. Last week, the people had sometimes a strong preference for things. So I thought we'd use this. Okay, so ladies and gentlemen, let's go and let's run our big population and go see what's changed. Oh, we should do build. Build early, build often, ladies and gentlemen. If you build often, if you make any mistake along the way, it will tell you. And so if you only do a few things before building again, a few things more, build again, then it will actually help you zero in on what went wrong, because it only could have been one of a couple things. If you wait half an hour before building again, you may have done 100 things and you're not sure where the problem lay. Okay, so build early, build often.
So as we build, it's saved as well?
Yeah, that's a good question. No. So save early, save often as well. It will build without it being saved, which I think is strange, frankly. I think it's a little bit strange. But all I could say is empirically. By the way, if I drag this, you'll notice there's a little star that appears here. Do you see this? This is called an asterisk. In some hacker communities, it's called a Nathan Hale, and that indicates the model's not saved. So if I build it, at least in previous versions, yeah, it doesn't save it. To save it, if I do Control S, it will save it, and then the asterisk disappears. Okay. Okay, ladies and gentlemen, I'd like you to run this model, and now here we have people. Let's go drill down to the level of a particular person. How do we do that? Through the navigation menu, and you'll see this is a person with age 58.47. Here's a person with age 77. Do you see that? Here's a person with age 75. Yeah? Okay. 75, 23, 67. Do you see this? if you kind of go through each person in the population, you'll see each age. Who needs help? Nolian help is on its way. Okay? Wong help is on its way too. Okay. Anyone else need help right now? Okay. Great. This is excellent. Okay. So, ladies and gentlemen, I would like now to do something with a little twist. Okay? We're going to add a value that instead of being continuous, is actually drawn from, it's categorical. We're going to add sex, male and female. Okay? Now, doing this is not going to be terribly hard mechanically, but it will teach a few things to watch out for in modeling, and it's a useful skill. I mean, after all, probably everyone in the room has either done an analysis where they've built one model or another that takes sex into account as a variable. Now, if we want to take sex into account in biostatistical analysis, often we'll encode it as 1 or 2 or 0 or 1, right? And that's fine. We could do that here. And, if we want to represent how many states of Australia are there, not including territories? 5 or 6? 5? Okay. Okay. Maybe Tasmania has left the union. Okay. Okay. So we could encode states, which state you're in as 0, 1, 2, 3. The problem is then we have the unseemly prospect of someone's sex being mistaken for a state, or vice versa. You could assign Tasmania to someone's sex, and both would be 0, and it would be perfectly, the model would happily accept it, even though it's nonsensical. So in general, when we build these models, we like a better way of doing things. We like to give things descriptive names that are clear. And so we'll actually see the name, we'll see it say male or female, or we'll see it say Tasmania, New South Wales, Victoria, Queensland, etc. Okay, so ladies and gentlemen, South Australia, right? So ladies and gentlemen, I would like you to now go, and we're going to add a mechanism to describe the sex of a person, okay? So in projects here, I'd like you to right-click on this and add a new type of category, okay? I would like you to add in a option list. Do you see this option list? I'd like you to add in an option list. And this option list will describe, this is an important point. It's not a small conceptual point that I'm trying to make. This option list will describe all possible sexes, male and female, okay? So we'll call it, to reflect that, we'll call it sex with a capital S, meaning it's all possible sexes, not some particular sex, like this person is male, this person is female. We'll have that later for a person. This is a set of all possible sexes. So we give it a capital S. Just like when we call colors, a set of all possible colors, we'll give it a capital C. Okay? And I'd like you to say female and male. Here. Capital, we could say capital, or we could do lowercase. I'd like to do capitals here too. Okay? Female and male. Are we okay with that? Okay. Okay. Great. So now we have sex with a capital S indicating sort of all possible sexes someone could be drawn from. Just as person with a capital P indicates all possible people. It's kind of a theory of personhood. This is sort of depicts sex as a characteristic. Okay? Okay, now, are people all done with that? So we added sex with a capital S. How did I do that? I right-clicked here. I said new, option list. I type sex, and I type female, male. Right? Okay, are we okay? So we've just added a category. Now, again, an important point here is that in agent-based models, you can associate a given person with categorical distinctions, discrete values for things, like the count of meals they have in their fridge that are, corn dogs from Safeway, or from 7-Eleven, or with continuous quantities, such as their income or their weight or their birth weight or what have you. So here, ladies and gentlemen, I would like to add a way of encoding their sex. Where would I put that? how would I put that in? What would I add? A what? A parameter to whom? To main or to person? To person, indeed. It's a characteristic of a person. So let's go to palette and let's drag in a parameter. And this parameter will be called sex with a lowercase s. Okay? Okay. Okay. So we dragged in sex, and its type is going to be, so this will be a particular sex a particular person will have. And what do you think its type will be? Let's pull down the values of type. Do you think it's the type of information associated? Which of these describes the set of all possible values it could hold? Is it a rate? Is it a length, a speed, acceleration? Is it a person? Is it a sex? Yeah, it's a sex. So we're going to pick sex there. Okay? Okay.
Is that always there, or is that appeared because we created it?
It's because we created it. It's because we created it. So if we added state, capital S, to indicate set of states of Australia, enumerating them, then it will be there as well. Okay? Okay. 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 So, thanks. So, ladies and gentlemen, now where would we go to indicate the distribution of values for sex? Where would that be encoded? Yeah, okay, so default value will give one. If we don't specify it somewhere else, it will use it. So we could give a default value of female, but that will just mean like if we forget to provide it somewhere else, it'll fill this in to use. But actually, where would we specify for a particular population? Where would we specify the distribution? Yeah, it'll be in main and where here? Population. So you notice right now it filled in female. Where did that come from? That's the default value. We want to fill in, ladies and gentlemen, a formula for how it would determine the sex. Okay, we can do this in several different ways. Okay, one way would be to say the following. We could flip a coin. It's a Bernoulli trial. Flip a coin with certain chance it's female, otherwise it's male. Okay? Are we okay with that? Okay. So I'm going to tell you how to do that. I'm going to give you a formula that it's going to basically say, flip a coin. It's going to return, that coin's going to return true or false. If it's true, use one value, female, otherwise use male. Okay? That's what we're going to do here. So this is what I'm going to tell you to do. Random true, 0.5. Basically, that flips a coin with 50% probability will be heads up, true. 50% probability will be tails up, false. It's going to be true or false with 50% probability. Okay? Okay. Ladies and gentlemen, so this is going to be true or false, but that's not what we need. We actually need it to be a sex, a particular sex. So if it's true, I'm going to have them be female. Okay? Otherwise be male. Are we okay with that? Okay. So if it's true, then we're going to have an if statement. If this is true, an if expression. If this is true, then female, otherwise male. And the way you write this is question mark. And you could say female, otherwise male. That's just how you write it. And I'll put this up on a construct that across my boot camps is known as the big screen. Okay? Here we go. Here it's going to be up on the big screen. That's what it is. Okay? And once you've done this, you could, So I removed it from the big screen. Once you've done it, you can build and see if it's a happy camper. There it is. Okay? There you go. Flip a coin. This is a Bernoulli trial, right? It flips a coin. True or false? If it's true, they'll be female. Otherwise, they'll be male.
And so I'll make a small aside on this. So there are, AnyLogic uses a programming language called Java under the hood. So this is Java syntax for saying, flip a coin. But there are many different ways to say the same thing. So AnyLogic has ways for you to say, here's a list of 10 things, give me just
A random
from
one,
them,
yeah.
all of them having the same amount of probability. So we could have said it that way. You can also make up custom distributions. So saying, there's 40% chance of being female, 60% chance of being male, and do that for 100 different types of values. So often you end up choosing whatever is most transparent or whatever is most economical for the situation. And in terms of these workshops, for putting a sex in really quickly to show you that we can go between males and females, this is a very dense and easy to type syntax. So if it looks confusing, just know that there are other ways to type this if it doesn't jive with you.
And if would people want to see a custom distribution? I mean, would you want to try that? Anyone want to see that? Couple hands. Okay. It's easy to do. It would take about 5 minutes. So you want to do it?
Yeah.
Okay, fine. So this is, personally, I don't like looking at this much. It's a bit verbose, and I'm grateful for Dylan for pointing this out. I think when we were over in Deacon, we actually did it with a custom distribution. So I'm going to do that now with a custom distribution. So, ladies and gentlemen, I'd like you in the palette. Yeah, it's good to know you have several choices. This is a very easy way to generate a value, true or false, and determine it. Let's go add a custom distribution. So in the palette, in the agent area, there's a custom distribution, and I'd like you to drag it in. And why don't you call it sex distribution? Okay? Good. Okay? Sex distribution. And what sort of type will this be? Do you think it's over continuous values, discrete values, or options? Well, okay, it's actually the way it's basically for categorical ones denoted with an option list. It's options. You notice by selecting options will allow us to choose the option list. What do you think we should choose? Yeah. Thank you, Dylan. That's great. Much appreciated. Thank you. Okay. 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 So here we can specify proportions. It calls them number of observations, but fundamentally they're proportions for males and females. So maybe we want females to be 0.5, 51% of the population, and males 0.49, something like that. What do you think? Okay. Jeff, the plot thickens. Okay, so 0.451, that means 51% of the time the value drawn will be female, otherwise it'll be male. Are we okay with that? Okay. Okay. Okay, who needs TA help? Annie sits ready. Okay? Okay, ladies and gentlemen, for population now, let's go replace this. Instead of where it said sex, what we need to do instead is something much sweeter. We'll just call sex distribution. Sex distribute. Remember, autocomplete is your friend. Please autocomplete. The TAs will be grateful for it. Now, when you autocomplete, this is the one you want. You want to call it. You want it to do work for you. You don't just want to say the distribution. You want to actually call it. So you need to have this begin paren, end paren. You need it to do work. It doesn't need It doesn't need any information to do its work, so there's nothing in between these. But you need to say, hey, do this work for me. And it will say, yes, ma'am. And it will do it for you. Okay?
Is that the distinction between the two in terms of that's actually a function? The other one?
Yeah, the other one is actually giving it the distribution. And that's kind of weird because you say, what should my, a person says, what should my sex be? And you say, here's a distribution. Okay, what do I do with that? This is telling it draw from the distribution. It's calling the distribution. The distribution will sample a value from it. It will draw a value from it. That's what that means. So let me make that distinction again visually, and this will come up. It's not the last time this will come up. It's the distinction in this and this. This means just give it the distribution, hand you the distribution, whereas this one, it's actually drawing from the distribution. Okay? So this is what you want. Can we run it now? Can we run it? What do you think? How about build? Build early, build often. Okay, make sure it's happy. Okay, Annie and Dylan are ready to serve. Okay? People, did you run it? Okay, great. Deployment has begun. Okay, so let's run the big population here. Ready? Run it, and let's go down to the level of the population. So now we see a person who's female, person who's male. Do you see this? Female, male, female, male. Yeah? You see it? Okay. So now we have a heterogeneous population. This is not to be minimized. In a system, an aggregate system dynamics model, adding in heterogeneity requires changes across the breadth of the model. Here, adding in an element of heterogeneity involves placing a parameter in a person. It's a very localized operation. Requires very surgical sort of changes. You can add it in, and importantly, you can take it out. Per the question before, if you discover, oh, well, this heterogeneity actually isn't as central to our question as we thought, you can remove it. It provides great flexibility. Okay, age and sex. Okay, that's great. Ladies and gentlemen, I'd actually like to now give these people an appearance. Okay? We're going to actually have them be visually distinct. Again, this is not eye candy. In this case, we're going through a little bit of a toy example, but in models in general, it can provide really helpful understanding of the patterns underlying the model population, understanding of the processes, the outcome of the processes. So, ladies and gentlemen, I would like to give each person a visual appearance. Okay? Okay. And we're going to build on skills you've already seen. Okay. So, I'd like you to go to person. And, well, yeah, I mean, if I want to have a person have a different appearance, where would I go? Main or person? Person. Good. That was not a trick question. Okay. Suppose I want their appearance to be different. Suppose I want to color this oval, or I want to make it bigger or smaller according to age. Where do you think I'd go within person to be able to change the characteristics of this oval? I go to the... Okay, I'll be doing something with the palette. Actually, I won't need anything with the palette in this case. I'll just be going to the oval. You'll notice selecting the oval, we have these properties here. And one of the properties is the color, the fill color. Okay? Okay? Okay, ladies and gentlemen, for the fill color here, you'll notice right now it's picking something, but you'll notice that if I go and I look at this, if I hover over this, under appearance, you notice it may be collapsed. You may have to uncollapse it. You see that? You may have to uncollapse it. Under fill color, you see that there's this equal sign here. I'd like you to click dynamic value. Okay? Click dynamic value. And by so doing, instead of using a predefined color that's fixed, we can actually specify a dynamic quantity. We can specify something that's changing in principle over time. You can specify a rule for what this color is, a formula or something, and a formula may be changing over time. It will actually change the color over time automatically for us. Okay, so here I want the fill color to depend on their sex. And let's suppose that we'll make women yellow and men gray, something like that. Can we do that? Can we do that? Unless people have another strong preference for color. Yellow and gray was one we've used for a couple of years now. Okay, fill color. So how would I say if the person's sex is male or is female, do use yellow, otherwise use gray? Well, we just saw something like, remember this if thing with a question mark and colon, that funny thing? We're going to be using that. Ready? So first I'm going to ask, is my sex, if my sex is equal to female, then use question mark yellow, otherwise use gray. Now I always forget, is it G-R-A-Y or G-R-E-Y? One is the family name, like Grey Poupon, and one is the color, and I tend to forget which is which. Okay, ladies and gentlemen, that's what I put in. Let me put that in the big screen. I want you to note that there's two equals here. That's because if we just put one equals, it'll be assigning, making sex female. If you put one equals, it means do this, make their sex be female. But here it's testing it. It's saying, is their sex female? And if so, make it yellow, otherwise gray. Are we ready for that? Can we, okay, build early, build often, run the model. Now, the secret is, if you run it, it automatically builds. But you may want to build other times before running it. So you actually don't have to build. If you're just going to run it, you could just run it. But it's a good habit to press build often. Okay, so can we run this thing? Okay, what do you think we'll see now? Okay, there we are. Who are the grays? They're the men. The yellows are the women. Okay, that's great. If we go down to a particular person, we'll see, oh, this person is yellow. Oh, it's a female. This person is gray. Yep, it's a male. This person is female, male. Here's another male. You can see their age. Okay, that's great. What if we want their size of this thing to depend on their age? How do you think we could do that? Where would we go in the model if we want the oval's size to depend on their age? Yeah, we go to the radius of the oval. So we go down to this area. It's not in the appearance area, it's in the position and size. And we go to radius. Okay? And what I'd like to do is to do radius here. Now, if I typed a formula here, maybe I want to make it be by age. If I start typing this, watch this. Ready? Started typing this. It's going to say invalid number. What do you think I have to do here to do it? Yeah, you have to make it dynamic by clicking there to make it dynamic. Now, these are little things about the framework, but we'll be building on them in the next few days. And to do things efficiently, it'll be helpful to know this. Okay, what I'd like you to do, ladies and gentlemen, is to do here this dot age divided by, I'm going to say divided by 20, divided by divided by by 4.0. Okay. This dot age divided by 4.0. So if someone's 80 years old, they'll be with radius 20. If they're 20 years old, they'll be of radius 5. Okay? What do you think we'll see now? Yeah, we'll see a population exhibiting variability. and visually that represents its variability in terms of the underlying characteristics. So once again, we could go down and browse at the level of individual population members. So so here's a smaller person is a bit smaller. Here's a older person. Here's a very small one, etc. Okay, so we'll go up. Now, this is not terribly instructive right now, but soon we'll be layering some patterns that depend on each other. And we'll start to see patterns in this that will elicit, we'll say, oh, okay, I know where that pattern's coming from, or what have you. Okay, are you ready? You ready to proceed? Okay, who needs a bit of help here? Okay, now we're going to add a little twist to the whole thing. We're going to add in, right now, are those aspects of heterogeneity have been independent. Those aspects of heterogeneity have been have not exhibited dependence on one another. Now we're going to add in a characteristic that will be dependent statistically on the others. I want to add to this person an income. How do I do that? You tell me. Where do I go? Go to person, and then where do I get a parameter from? From whence does the parameter come? From agent parameter. Yeah, the agent palette. That's right. And we can drag this over, and we'll call it their income. Now, oops, we could make it their income decile or their income quintile or whatever, but we're going to make it their continuous income. Okay? Now, with your leave, I'm going to leave out default value. Instead, where are we going to specify the income distribution for the population? We have to go to main, and what in main? Population. Okay, now, for the income distribution, we're going to specify a value here, okay? So, here we go. And I'd like you, ladies and gentlemen, for this value to choose to write a distribution. A log normal distribution with log mean, that is mu, 10.5, log standard deviation 3.5, and minimum value, which in this case won't be binding, it can never be less than this anyway, of 0. So this is going to be a log normal distribution. Let me put this up on the big screen. So this is the log mean, in other words, the mu. This is the sigma, the log standard deviation, and this is the minimum value. Are we ready for that? Okay, now we're going to do a twist of this now. Okay, so first of all, let's run it. Just make sure it's running fine. Build early, build often, and let's run it and see what, and make, browse through and make sure, yeah, are they assigned an income, properly an income. Okay, so we go down to the person. Here's a person with an income, a monthly income. Oh, this person has a very high monthly income. Okay, here's a monthly income. Thought it was supposed to represent monthly income, but probably these are yearly. I must be misremembering. Even in the U.S., one's unlikely to see a monthly income of $317 million. Although with one wonders. Okay, ladies and gentlemen, but now I want to add some twist to this. I want to make the visual appearance, ladies and gentlemen, be dependent. The X location depend on the income. Okay, so ladies and gentlemen, where would I go to make a person's X location dependent on their income? In the okay, now the oval is a good idea. After all, the position of the oval, you can actually specify the X location, for example. But in this case, we actually want their not just their appearance, but their logical position. to be at that position. Where does their logical position set? Does anyone remember? Where do we set a uniform distribution between 0 and space width for their x? Remember that? It was in the population. It's in the population. So if we go to the population, we'll see their x location was set. Remember this? Do you remember that? Okay, ladies and gentlemen, for their x location, we want this to instead depend on their income. Okay? Now, how are we going to do that? Well, this is you'll notice that any logic gives us a hint. It says, there's this thing called self here. And that allows you to refer to the characteristics of the person. So I'd like to make their x location, ladies and gentlemen, dependent on their income. Okay? So I'd like to make x be dependent on self.income divided by 100. Okay? Divided by 100. So their x location, or 100.0. It'll save you grief if you take care to give things that you mean to be continuous values, you call them 0.0 rather than just putting the number. Yes?
Can we use, say in a study, can we use the actual characteristics?
Yes. Yes. You could read them in. And in fact, this, so I'm going to, don't do what, well, here, I'll go down and do it here. You'll notice that another thing saying is using index. And using index, you could read it in from a database, for example, or look it up in a spreadsheet, or draw it in from a file. And by reading it in, you could populate this not with, people drawn from distributions, but with data drawn from an administrative data database, or some sort of longitudinal study information. You could do it using that index characteristic. We'll try to have a session on input and output on models if we have time here. Otherwise, there's a lecture with me where I'll talk about reading values in from Excel sheets. Dylan here also can comment some on that, and possibly Annie as well. Okay? Okay. Great question. That's another mode of doing it. In these sessions, well, our models back home actually have tended to make quite heavy use of databases, reading values in, putting values in, or reading them in from an Excel spreadsheet. To do so at these boot camps is challenging because it means needing to set up a database somehow and have the database be up and maybe a network connection to it, and it just adds a lot of complications. So we've tended to underplay that side of things. But AnyLogic particularly recently has tried to make it even easier to draw data in from databases, but already it was very straightforward if you just knew how to go about doing it. Okay? And Dylan, myself, and maybe Annie could talk about that. Okay? Yeah. Okay, ladies and gentlemen.
Okay.
Yes.
This and self.
Yes.
Don't they mean the same thing? Why sometimes you need self?
Okay, this is a great question. It's because right now we're in main. This will refer to main. Okay? And self refers to the person, the thing that's being created, the person in the population that's being created. So it gives it the word self. It's only one of two places in AnyLogic where it's used. The other one will be up here, as we'll see in a second. That's the only two places where I know it's used. And it's a little bit of a pain to know, but it does give you that hint, and it's just one of those things. Okay, so here we see, what is this representing? Anyone? What are we seeing here? It's the income distribution. Income distribution is that people's incomes go along the x-axis. These people out here, could you characterize in a word what constitutes these people out here to the right-hand side? Yeah, they're the rich people. They're wealthy individuals. Individuals of means, whatever. I think investment companies have very general sort of nice sounding ways. They're prosperous individuals, right? And then way down here on the left-hand side are individuals who are increasingly dominant, who are lower income individuals who are suffering real disparities at the bottom end of the spectrum. And you can get a sense of some of the distribution. By the way, I'm scrolling out, and it will zoom out when I scroll it, and I'm right-clicking to sort of click along here. But I can zoom in and out using this. Okay, ladies and gentlemen, now I would like to go one step further with this, and then we will move on to a new phase of our work. To wit, ladies and gentlemen, I would like to make now two different distributions, one for men and one for women. Okay? So there'll be a male income distribution, a female income distribution. And in the interests of time, because time is a fleeting tempus fugit, we are going to put in place very simple distributional assumptions. So I would like you to tell me what to do. I would just note that once again, that self will refer to the person characteristics here. Suppose I wanted their income to depend on their sex. How would I put in a formula so that if they are female, they'll be of one distribution, otherwise another distribution? We know there's very large wage disparities in many areas of the world between men and women. Very large differences, probably representing real inequities, not merely disparities, but not merely inequalities, but actually some real problems whereby women for the same work might earn less money. So if we want to capture that, suppose I want, if you are male, you draw from one distribution and otherwise from female. How would I do that? What would I write here? Anyone? We've seen it twice now. Yes, okay. Okay, so self, you actually do self dot sex. Self because of this thing that in these areas you have to refer to self. Otherwise, you just about got it right. This would always be used inside of person, okay? To refer to the person. If you're inside a person, you could call themselves via this as the person. Here, because we're inside of main, you can't use this. So if self.sex, and then what do we do? Equals, exactly. Female, and then what? Question mark. We'll use one log normal distribution. We'll draw from one log normal distribution. Otherwise, we'll draw from the other. And for females, I'd like to make it 10, 3, and 0. And for men, I'd like to make it 11, 4, and 0. Okay? Okay, here we go. Okay, let me put this up on the big screen. You'll notice I'm leaving white space. That white space is optional, but it makes it easy on the eyes. Okay? And in my code, the eyes have it. Okay? So this is what I put in. Oh, and by the way, I really sort of, by the same token, I really should have done 10.03, just to be careful. You will be burnt. If you're not careful with this, sometimes you'll be, it won't be in these cases, you'll be with division. If you don't put in the divide, you will be burnt. And it's just good as a habit for beginners to learn to put in extra, put in some decimal points, just to be sure that it won't be misunderstood as an integer. I'm sorry to say it, but it's a fact of life with this, that sometimes it will matter with division specifically. So it just, I generally encourage people in my boot camps, if you're a beginner with respect to this, put in, just get in the habit of using these things, you won't be burnt. Okay, so here we go. Are we ready with that? Are we ready? Okay, so ladies and gentlemen, let us now run the model. What do you think we'll see now? Yeah, unfortunately, there's a lot of men. There's a lot of men. Okay, so sorry, I've got to get. Here we go. There's a lot of men who are wealthy. So we're going to run this. I'm going to zoom out, and here we see at the upper end of the spectrum more men than women. That's reflective of the higher values associated with men. Okay, the higher income values associated with men on average. But down at the bottom end, there's a lot of mixture. Okay. Okay. And then maybe I'll do one final thing here, which will be which will make it a little interactive. You'll notice down here there's a real mixture. Slightly more females. Okay, ladies and gentlemen, I would like you now to go to person, and we're going to have it so when you click on a person, it'll print out their characteristics. What do you think of that? Is that okay? So I'd like you to go to person, and I'd like you to click on this oval. Do you see that? And I'd like you to go to on click here. Okay? There's down in the advanced area, there's on click. Okay? You could tell your colleagues when you go back after the class that before, just after 3 p.m. on the first day, you were doing the advanced area of any logic. Okay? Okay, so, and this is true. I didn't show this in my last boot camp. They had other priorities to emphasize, but here we're going to hit on this one. So when you do on click, I'm going to write something out. Now, I'm partly doing this because I realized last boot camp I didn't hit a certain issue I really should have hit early on till late. So I'm going to have this print out. When you press on click, we're going to write a bit of code here. And this code will be different from what we've written thus far. Right now, we've been writing formulae. We've been writing these formulas to calculate values. For the income, we gave a formula. For the sex, we gave a formula. For the age, we gave a formula. And for the color, we gave a formula. For the size, we gave a formula. Here, we're not going to be doing a formula. We're going to be telling it commands. We're going to be telling it injunctions. We're going to be saying imperatives. Do this, do that. In this on click, we're going to be putting things that are called statements in Java. Okay, they're commands. And therefore they will have to be followed by a semicolon. Okay, are you ready for these statements? Watch this. Okay, I'm going to put in a statement. This will be one of your favorite ones if you work with these models. Trace ln. This will mean print something out as a trace statement. Trace ln, my income. So, or you could say my name is, and then do a plus and say this. So I'm going to put this on the big screen. Okay, here we go. My name is this. And then I'm going to say trace ln. This plus basically means just append, concatenate. So to put this word, my name is, and then put however you put my name, however you print out me. Okay? And then my income is plus, and I'm going to do this dot income. And you say my sex is this dot sex. Notice I'm just copying from one line to the other because it's almost the same. And finally, my age is, okay, my age is this dot age. Is that okay? Okay. Okay, I'm going to go put it in there. Boom, just like that. Just like that. And I'm going to press build just to make sure I haven't told you to do something bad. And there we are. Okay? Are we okay with that? Okay. What this means is when we click on someone, they will print out all this information. They'll print out their name, their income, their sex, and their age. And as you might expect, if this were drawn from a database, it might print out their ID, right? I am study ID such and such. Okay? Ladies and gentlemen, are we ready? Do you want a bit more time? Remember, for these latter parts, autocomplete is your friend. It won't autocomplete the string because this thing here. This is called a string. It's just a quote. It'll say exactly my age is. Whatever's in there directly, it will say. But then it will, after that, it will say their sex. This one isn't quoted, so I'll actually compute what is their sex. And then it will append it here. And then that thing will print out. Are you ready with this? Okay, who would like a little bit more time? Dylan stands ready. Are we ready to run it? Okay, let's run it. Okay, run. And unless we do something, we won't see anything different. What do we have to do in order to get it to do that? Anyone? You have to click on someone. And you see this? Click. See that? See what it's doing? It's in the console window. Do you folks see a console? Like, here, I'll make mine small so you can see it. It's in this thing called console. Do you see that? No? Okay. Go. If you don't see it, Annie, could you help people? If you don't see it, you may have to go up to View and choose Console. Okay. So View, Console, and then you will see it. Okay. And each time I click, you should see it print things out here. So my name is root.population10. My income is this. My sex is male. My age is this. Do you see that? In the console? You see?
I see the name, after the name, there's parentheses, age, income, and everything. So
Oh, interesting. Okay. Annie, could you? Sure. No, that console wasn't visible for some people. So I suggested they enable this. But then Shawen noted that in hers, it seems to print everything out automatically.
Well, mine prints age and income.
There's a huge amount of people under the mouse in that left-hand column. So when you click on one, it's this person,
Yeah.
this person, this person.
Yeah, I saw that, but Shawen also saw.
I have age, income, and all that.
Yeah. I think it's an AnyLogic version.
Yeah, it probably.
It's just an AnyLogic version.
Yeah,
I have an earlier
she's
version.
7.2, so
Yeah.
I know that some of the versions have the ability to do kind of like a smart two-string.
And we actually have a database created
Yeah, so you have
right
some.
at the beginning.
Right.
Which you said.
Right. Which you can use. Yeah, you could use actually to store away information from the model or what have you. But. Okay. So do you folks see information being printed though? Okay. So is the console window visible, Annie? It is. So he was able to see it? Okay, great. Okay, who else? So over there, Annie? Yeah. Anyone else do this? Okay, so ladies and gentlemen, let's just step back for a second. It's time, I think, for a food break. Is that right, Jeff? But let's take stock of what we've seen. Let's go back to kind of the lessons learned from here, okay? So lessons here, we, within an agent-based model, we can associate agents, and in fact main, with characteristics as encoded by parameters, with these properties. When we talk about agent-based modeling, we'll often describe the situation in terms of what Ross Hammond will call party framework. I call it parties. And the first thing is properties, which in any logic correspond to parameters. These are sort of characteristics of a person. And in my rendering of this, these are more or less static characteristics. Things for the sake of the model you treat as static, as fixed. Sex would be a good example. Ethnicity, another one. In this model, we're not looking at income dynamics, and so maybe you treat income as static. And these are, in any logic, we specify these with parameters. One of the challenges with certain types of dynamic modeling, particularly aggregate models, such as are very common in system dynamics, is that it's difficult to represent population heterogeneity. But we know through much of the literature that often in the health area that heterogeneity makes a disproportionate difference. It's not merely, you can't just merely deal with the mean, the average person, the typical person in the population. Sometimes the tail wags the dogs. A small section of the population, small vulnerable group, can be disproportionately responsible for much of the health burden and potentially for transmitting norms, attitudes, beliefs, pathogen to the remainder of the population. So you can't just deal with the typical case. You have to deal with the variety of people in the population. So representing heterogeneity is often front and center for many characteristics. And we're going to see throughout this boot camp many ways of representing heterogeneity. Spatial heterogeneity, heterogeneity where people are in GIS space, where they are in networks. But here, we've been off to a good start where we've introduced people with both continuous attributes like income on the one hand or age on the other, and with discrete attributes, or categorical in this case, male, female, for example, okay? To capture those aspects of heterogeneity on the part of a person. That is significant, ladies and gentlemen, that we can so readily capture aspects of heterogeneity, add them in, alter our assumptions about them, etc. Now, as asked before, suppose we had several populations. Maybe this is a meta-population model, and we actually want to capture differences between populations. Well, here in Maine, we could have a population of a Melbourne population, a Sydney population, an Adelaide population, and each would have different distributions associated perhaps with their income, for example, up here. Each would have a different distribution with their by sex, each a different distribution by age. So one could readily do that. We also know that you could read information in from databases. So we can have a richly heterogeneous population here. We also can represent populations where the size of that population will vary as a function of our assumptions in the model, specifically here with experiments. And we saw that by introducing a parameter into Maine, with different experiments, we could assume different things in terms of those parameters. So we can ask what-if questions involving assumptions that are encoded as parameters. And that's going to be our primary means at a mechanical level for asking what-if questions. It's through the use of parameters to communicate those assumptions from the experiment on the one hand to Maine on the other. So we're going to put parameters in Maine, and that will mean that those parameters will appear here in this parameters area of the experiment. We could add 3 more parameters in Maine, such as about the population mean for income, and those could be, for example, down here in the parameter section. So parameters serve as a key means also of asking what-if questions. So we can readily, within the context of these models, support a representation of heterogeneous populations, of populations where characteristics of individuals vary widely, and often we'll either draw those characteristics from distributions or from databases or other sources of information that we may want to populate. Okay, so ladies and gentlemen, we're going to have a break now. We will then continue on to discuss how we represent dynamics for the population. Thus far, we have some rich aspects of heterogeneity, but we have done nothing to capture dynamics, behavior over time of individuals. How those people's status changes over time, which after all is central to the enterprise of dynamic modeling. So after the break, we're going to then apply our growing knowledge of any logic to build up models that exhibit dynamics. And we will do so on top of that existing model we've already started. Okay? So that's what we're going to do. So I think we'll take a 10-minute break here, and we'll reconvene at about 35 past to make that final push associated with representation of dynamics. Okay? So thanks very much, and see you shortly.